Hello, ladies and gentlemen. Today we're going to start the second part of our unit, and that is graphing quadratic equations. So we've been talking about equations that have an x squared in them. Those are quadratics, that lead coefficient with an x squared. And now we're going to take a look at what they graph to make. So we need a calculator, something to write with, as well as your notes. You're going to be making some graphs today. So either you're using your graph paper notebook, or you have some little graphs that you're going to tape in there, however you want to do that, but you're going to be sketching some graphs. So where we have been this year so far, we've graphed lines, those are linear equations. We've graphed lines and then we've shaded either less than or greater than. Or we've also graphed these beautiful absolute value functions into V shapes. And now it's time to make the U-shaped graph. Good news is you've already seen a U-shaped graph from Algebra 1. You maybe just didn't spend as much time on it as we're going to. So we're going to start with graphing quadratic equations when they're written in standard form. This is where your notes begin today. Standard form will look like this. You're going to have a y equals, or maybe an f of x equals, because that's the same thing as a y. And you're going to start with an x squared term, so there's going to be an ax squared plus a bx plus a c. Now standard form is pretty much the same way we've written our quadratic equations when we were going to solve them. We'd like the x squared first, then we'd like the x, then we'd like the constant at the end. So this is nothing new to us. The only thing that's new is that we have a y equals this quadratic equation rather than it equals to 0 or anything like that. So these equations will graph into a U shape called a parabola. So let's talk about key features of a parabola. First, I need you to make a little sketch of this U shape in your graph paper notebook or on your notes. And it doesn't have to be perfect, doesn't have to go through these points, but there are some key features that happen on a parabola that we need to be able to identify. First of all, again, the bottom down here is called the vertex, the turnaround point, if you will. The vertex, just like it was on an absolute value equation, except now we're talking about a parabola or a quadratic equation. Also, these graphs will likely have x-intercepts. They sometimes are called roots or zeros. Now, not all parabolas have an x-intercept, but many of the ones we're going to look at will. Also, when you think about a parabola, there will be an axis or a line that we can draw down through the center of the parabola that we can use as sort of the line of symmetry was for you in geometry. So it's called the axis of symmetry, and that means if I were to fold the parabola in half, it would be folded on this line, and then the left side would match up perfectly with the right side. That idea of a parabola being symmetric is very important. So now we're going to actually sketch a couple graphs of parabolas. So right now I'd like you to pause this video and sort of get this layout down in your notes first. There's a lot to write and draw, and I don't want you to have to worry about writing all the words and drawing everything when we're going through the example itself. So sort of pause the video right now, set up your table, write the equation down, write down the key features that we're going to identify, and if you don't have a graph paper notebook, you might want to tape in that little graph up in the corner. Okay? All right, so you may have paused, hopefully, and got your page all set up. So we're going to make a little picture of this quadratic equation. So we have y equals x squared minus 4x minus 5. We know that this is going to graph into a parabola because it has x squared as the lead coefficient, and that's the highest power. So when we make a graph of a parabola, we have to be careful what x values we choose for our table. Parabolas aren't like lines where they have a slope we can just count and that sort of thing. We need to make a table to help us plot these points. Now, we can't just choose any x values we want. We need to make sure that we see both the left-hand side and the right-hand side of our parabola. So the middle x value in your table is always going to be found using the little formula negative b over 2a. So in our beautiful quadratic equation we have up here, the b is a negative 4. So if I were to negative a negative 4, I would just get a positive 4 over 2 times the a in our quadratic equation above here is a 1. So what I have is 4 divided by, this would be 2 on the bottom, so I have 4 divided by 2 gives me an x value of 2. That means the x value of 2 has to be in the middle of my table. It's going to help me find the vertex. So we need to choose some other x values on either side of the number 2. So like 1, 0, 3, 4 perhaps, okay? And once we've chosen those x values around that vertex point of 2 here, now we go ahead and we plug in our chosen x values into our quadratic equation. So I'm going to plug in the number 0 everywhere I see an x. So 0 squared minus 4 times 0 minus 5. And if I calculate that just like that in my calculator, I end up with an x or a y value of negative 5. Now I do the same thing with the number 1. 1 squared minus 4 times 1 minus 5. And again, I make sure that I type that in my calculator correctly, and I get a y value of negative 8. 2 squared minus 4 times 2 minus 5. And if I type that in my calculator, I get a y value of negative 9. 3 squared minus 4 times 3 minus 5, and I get a y value of negative 8. And 4 squared minus 4 times 4 minus 5. And if you type that in your calculator, you get a y value of negative 5. Now notice some of these y values are repeating, right? We want that. That's good. That signals that we have some symmetry going on. So let's plot this. 0, negative 5 is 1 point on my parabola. 1, negative 8 is another point. 2, negative 9 is another point. And then 3, negative 8. And then 4, negative 5. Now notice the sides of the parabola don't have a constant slope. It's not up 1 over 1, up 1 over 1, up 1 over 1 like a V shape was. That's because the sides of this parabola are actually curves, making it a U shape and not a V. Okay, there's a sketch of my parabola. Now let's identify some key features. So the domain is what x values can this function or does this function have or does it use? Now notice we have arrows on either end, right? So if I were to fold in the sides left and right, I really couldn't. My domain goes from negative infinity to positive infinity. And we wrote it earlier like this with our beautiful parentheses, okay? Or you can also write it, or may see it on an ACT as all real numbers. This is the symbol for all real numbers. It's a fancy R. Either way is fine for me. You can write it using interval notation, or you can write it using set notation. This is called real numbers, okay? Now range, let's talk about y. So the lowest y value down here is negative 9. Notice that's as low as the parabola goes. The rest of the parabola is above that value. So we would say the range goes from negative 9 until positive infinity. So the lowest spot it's negative 9, and then it'll continue to climb and climb and climb till positive infinity. This is, again, is interval notation that describes our range. So now let's identify the vertex. The vertex would be this point right here. That is the point 2, negative 9. That's not an interval, that's a point. Now the axis of symmetry would be, where do we fold this parabola? I could fold that parabola right here through that vertex. That line is the line x equals 2 because it goes through the x-axis at 2. So the axis of symmetry is the line x equals 2. The x equals is really important because there are several places on this graph we could use if we just write the number 2 as our axis of symmetry. Now what's the minimum or maximum value? Now on this parabola we have a low spot, so we have a minimum value. How low does it go? It goes all the way down to where y equals negative 9. Now let's talk about increasing and decreasing intervals again. So decreasing would be how my car starts, right? I'm decreasing on the negative infinity side. There's my little car driving down, 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 until it hits right here. The x value right there is 2. So I am decreasing from negative infinity until 2. Then my car would turn around and start climbing up. So at the x value of 2, until the positive infinity side of the graph, I would be climbing up this parabola. Okay, so some of these things are review, some of them are new. Let's take a look at one more. This one's a little bit more difficult because it has a few more negative signs in it, but we'll use the same sort of setup and the same procedure to make a graph of this parabola. So the very first thing you need to do is find the middle x value for your table, negative b over 2a. The b in this case is negative 2, so if I negative a negative 2, I get a positive 2 over 2 times the a value is negative 1. Look in front of that x squared. That's the a. It's a negative 1. So what I have here is 2 over negative 2, which would give me a value of negative 1 for my x value. Now I need to choose x values around negative 1, like negative 2, negative 3. On the other side of negative 1 would be 0 and 1. And now I need to carefully plug my x values into this equation up here. Now notice the equation starts with a negative sign, and then the x value we want to plug in. So I'm going to keep the negative sign, put my negative 3 squared minus 2 times negative 3 plus 8. And if you carefully type that into your calculator, you're going to get a y value of 5. Yes, the parentheses are all important. You need to be sure you're typing that in correctly. Okay, again with the negative 2. Negative sign, negative 2 squared minus 2 times negative 2 plus 8. And if we type that in our calculator, we get a y value of 5. And I'll repeat the same procedure with the negative 1. And if I type that in the calculator, you get a y value of 9. And I think you probably know what the 0 is going to do, but let's just set it up anyway. We know it should repeat, right? This should be a y value of 8. And one more time with the number 1. 1 squared minus 2 times 1 plus 8. And we go ahead and get a y value of 5. So let's plot our parabola. I'm going to go over negative 3 up 5. Over negative 2 up 8, over negative 1 up to the 9, 0 to the 8, and 1 to the 5. There we go. There's the parabola. He's upside down this time. Gee, I wonder why. Hopefully you aren't wondering too long. There was a negative in front, right? That's what flips him over. Okay, now let's talk again about domain and range. So the domain again, because there's arrows on both ends, we're going to say the domain goes from negative infinity until positive infinity, or like I said before, you can also say it's all real numbers. Now the range is the y values. Notice that the parabola has a high spot up here at 9. Every part of that parabola is underneath this y value. So 9 is the highest it's going to go, and it's going to continue on for negative infinity, right, until all those negative y values happen. So my range is from negative infinity until positive 9. Notice I wrote the negative infinity first, and that's just because he's smaller than positive 9. Now let's do the vertex. Vertex would be way up here at this point. Negative 1, 9 is the vertex. The axis of symmetry, where would we fold this parabola? Right here through negative 1 on the x-axis. So I'd say my axis of symmetry is x equals negative 1. Do I have a minimum or maximum value here? Well, this is like a mountain peak, right? I have a maximum, a height way up there. How high up does it go? Where y equals 9. That's the maximum height. Now, increasing and decreasing intervals. Let's start the car on the left-hand side. I would be driving up until I hit this point right here, which has an x value of negative 1. So increasing from negative infinity side of the graph until negative 1. And then I'd be decreasing from the x value of negative 1 until the positive infinity x values happen. So I'd be decreasing from negative 1 to positive infinity. Okay, so we've taken a look at graphing a couple parabolas today. Hopefully some of it's repeat from Algebra 1 and some of it may be new. All right, thank you for taking good notes, you guys. See you later, Savers. Kincaid out.